Now let's talk about the heap. What is the heap and how is it different from the stack? So the heap is a region of the process memory that is not automatically managed for us. We have to manually allocate memory there and, very importantly, manually free that memory once we are done using it. Failing to release heap allocated memory leads to memory leaks. It has no size restrictions. So as we know, the stack has a size limit, but the heap can store huge amounts of data. It is only limited by the amount of physical resources of the system. It is accessible by any function anywhere in the program. So again, as we know, variables on the stack are only accessible by the function that allocated them. But everything on the heap is accessible by any function in the program. And heap allocations can be expensive and we should avoid them when possible. Because if a program allocates and deallocates a lot of blocks on the heap, eventually the heap will get fragmented, and that makes it much harder to efficiently find the necessary space for new allocations. So again, let's walk through an example to understand this better. As we can see here, we have a program that's quite similar to the one that we had in our stack example. So again, we have a main function that creates a local variable and calls the stack only function passing that variable. The stack only function accepts a parameter, creates a local variable, and then it calls the stack and heap function. And this is where it gets interesting. The stack and heap function creates a local integer, and then it manually allocates an integer on the heap. Let's see how that would work. So for this we need a stack, but also we would need a heap. So again, let's enter our main function. We see that we have our stack frame. We put our local variable there, and we jump to the next function, which puts all of its local variables on the stack, and then we jump to the stack and heap function. So now the stack and heap function creates its local integer that goes to the stack, and now we have to allocate memory on the heap. So in this case, as we can see, the heap is completely empty. The reason for this is that our program has not allocated or deallocated any memory yet. But if we imagine that we were running a program that was intensively allocating and deallocating memory, the heap could look like this. It can be fragmented, and that makes it harder for the allocator to find the necessary space. So this can slow down our allocations. In this case, our heap is empty, so our allocator will just go find the right spot and then put our integer, in this case 7, there. And here on top we see that this is the address, the memory address of that space where we put the integer. And then on the stack, we only store the address for that memory, as we can see here. So later, when we want to actually access the value that we put on the heap, we just follow this address. This address is called a pointer, and following it is called dereferencing it. So when we dereference the pointer, we actually get the value that we stored on the heap. The size of the pointer is known at compile time. It depends on the CPU architecture, but generally it is 32 or 64 bits. So this is how we store memory on the heap and how we can still reference it from our functions by storing the address of that value on the stack. But as we said, we have to manually allocate memory on the heap, but also we have to manually deallocate that memory after we're done using it. But here our function does not deallocate the memory. So when the stack and heap function exits, we see that its stack frame is gone. We have lost the pointer. We no longer know where we allocated memory, but the memory is still there. This memory cannot be reused. So in this case, we have a memory leak because this memory will stay here until our program exits. And there's nothing we can do about it now. If we keep following the execution, we exit the stack only function, then we exit the main function, and when our process exits, our memory is released. We have to remember that we always need to deallocate manually the memory that we have allocated on the heap. This is crucial.